started. Chapter 1 is our chemistry basics. We're talking all about matter and all about measurement. So here's our outline. We're going to start today on classifying matter with pure substances and mixtures. So in order to really discuss matter, we have to understand how it's classified and how we organize it. And we know that matter is anything that takes up space and weighs something. So when we talk in scientist terms, taking up space is called volume. And if it weighs something, we call that mass. So when you look at matter, anything that takes up space and has mass can be either divided into a pure substance or a mixture. Let's talk first just about pure substances. Pure substances are all one thing. The simplest pure substance is going to be an element. And where do we find elements? We go to the periodic table. And we find any element on the periodic table, that's a pure substance. So for example, gold, right? It's a lot of people's favorite pure substance. You find it on the periodic table, AU. AU is gold. That's a pure substance. Any one element that you pick off of the periodic table is a pure substance. Now, some elements on the periodic table in their natural states will bond to themselves. For example, hydrogen gas bonds to itself. So you have hydrogen bound to a hydrogen with a covalent bond. It's still all hydrogen. It's still all one thing. And that one thing is the same element, the same kind of atom. And so these are also pure substances. So there are a couple of different ones that will do this. Oxygen will do it. Oxygen will bind to itself. So we call this H2. We call this O2. So anytime you see that, where it's just one element and it has a little subscript number, it's just telling you that it's two of the same atom. And so those are all still classified as elements and pure substances. Compounds, on the other hand, compounds are more than one element. So this is more than one element. This is one element. Right? So we can keep them separate. So we have more than one element, that's true, but it's more than one element and it's represented by the same chemical formula. So no matter where you go in the world, if you say water, water is always represented as H2O. 2 hydrogen atoms, 1 oxygen atom. That is the same formula. So if you have a big glass of water, right? All this is water. All of this water is exactly the same. All of this water is H2O. Another example is table sugar. The sugar you put in your coffee or whatever it is, it's going to be C12H22O11. Every time we say table sugar, that's the chemical formula for table sugar, and that's what we're referring to. So that is a pure substance, because if you took a spoonful of table sugar, everything on that spoon is all C12H22O11. So that's all one single type, one same chemical formula. We've got multiple elements in there, but it's the same chemical formula. All right, now we're going to talk about a slightly different classification of matter, right? We're going to go over to the other side. We're going to talk about mixtures. Mixtures are where we have more than one compound, right? So if you take two things and mix them together, let's say, for example, you take your sugar and your water and you put them together. Well, you have a glass of water, right? This is a terrible glass of water, but anyway, I'm going to go ahead and put my sugar into my water, and here's my water. What's going to happen? You stir it around. What happens to those sugar molecules, those sugar granules? As you stir it, they start to disappear. They're dissolving. So when I'm done making my my mixture of sugar water, I have one thing. You look at it and it just looks like water now, but it all looks the same. Same thing if you have a packet of Kool-Aid and you pour your little pack of Kool-Aid and you swirl it around, it's all going to look the same. If you pick the strawberry flavor or whatever it is, it's all going to be red. So that's a homogeneous mixture. It all looks the same. So when you see the word homogeneous, I want you to think same. The opposite side of that is if you mix two things. Let's say I have my pitcher of water, and instead of putting Kool-Aid in it, I'm going to put rocks in it. Yeah, I said rocks. If I swirl it around, doesn't matter how long I swirl it, what's going to happen? My rocks are still going to be at the bottom, and then I'll have water. Can you tell the difference? Can you look inside of that pitcher and can you see the difference between the rock and the water? Absolutely. So that's a heterogeneous mixture. You can see the two different things. So when you think heterogeneous, I want you to think different. R-E-N-T. Okay, different. So what else do they have? Vegetable soup is an example, right? I have my big pot of vegetable soup. I'm going to put carrots in there. I'm going to put broccoli in there. I'm going to put potatoes, all that kind of stuff. If I take my bowl and I get a scoop of vegetable soup and put it in my bowl, can I see the different things that I put into my vegetable soup? Absolutely. And I can pick them out, right? So that's heterogeneous mixture where we can see the different things. So now that we've kind of gone through this table, let's go through and look at the actual notes. Oh, why are we doing that? There we go. So we said that matter is classified into one of two things, either a pure substance or a mixture. So here's if we have matter is classified as either a pure substance or matter is a mixture. So if you are a pure substance, then you are either an element or you are a compound. Remember, element is only one type of atom. One type of atom. If you are a mixture, you can either be classified as homogeneous or heterogeneous. Remember, homogeneous, we said that same. Heterogeneous is different. Right? Okay. So let's focus in on our pure substance. Pure substance is matter that is made up of only one type of substance and can be represented with one chemical formula or symbol. If it's only one symbol, right, it's an element. It's the simplest type of matter because you only have one type of atom. So we said our example was iron. That's one type. It's metal. Oh no, we didn't say iron, we said gold, right? AU. That's another example. Another example we said was H2, hydrogen gas. Each of those three examples are all made out of one type of atom. So that is an element. And we know that an atom by definition is the smallest unit of matter that keeps its unique characteristics. So no matter where you sampled that gold, it's all going to be exactly the same. On the other hand, a compound, right, is two or more elements chemically joined together. So if we have hydrogen, that's great, but I want to combine it with oxygen. So I'm going to put a 2O, and this is how water's formed. We have two hydrogen atoms that are chemically joined to one oxygen atom. So that's an example of a compound. NaCl is an example of a compound. It tells us that for every one atom of sodium, we have one atom of chlorine, right? So that's table salt. A mixture. A mixture is a combination of two or more substances. Oh, let's think about that. So two or more substances. So if we had water and we added NaCl, that is salt water. Is that a mixture? Yes. The water and the salt don't chemically alter each other, right? But if you put salt inside of water, it's going to dissolve. And so you're going to have a mixture. a mixture is something that you can separate into its different components. So physically, I can very easily separate salt from water. All I have to do is heat it, the water evaporates, and the salt basically gets left at the bottom, right? So that's a mixture. I could easily separate it. And that water and salt was actually an example of a homogeneous mixture, because if you put salt in water, you can't see the salt anymore. You can't tell the difference between the salt and the water. So that's homogeneous because it's the same. But if I took sand and I mixed that with water, I would still have a mixture, but I would have a heterogeneous mixture, because the sand would settle to the bottom. Even if you stirred it, sure, it would swirl around for a second, but then it would settle down. And so the composition is not uniform, it varies. And so you'd be able to pick out the sand with like a filter, right? Okay, so here's our overall classification of matter. We can separate it into one of two things, either a pure substance or a mixture. We said pure substance is the simplest, is an element. You go find that on the periodic table. So our example here, copper atoms. These are some copper tubings. But anywhere where you sample here, 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 it's all just copper. Or you could have a pure substance that is made up of more than one atom, type of atom. So our example here were water molecules. So we had H2O. So we have more than one kind of atom here. We have hydrogen atoms and we have oxygen atoms. So that's a compound. Mixtures, on the other hand, right? We can separate them. So here's an example of brass. Brass is a homogeneous mixture. We take copper and we take zinc and we heat them up, right? And we create an alloy. So it's a metal that is a mixture of two different metal atoms. And so anywhere where you pick on this instrument and you looked at the amount of copper and zinc in these two different places, what you would see is that you have the same ratio of copper to zinc. So it's a mixture, yes, you have different types of metals in there, but it's homogeneous because it's all the same. You could also have a mixture that is heterogeneous. Heterogeneous is where we can see the difference. So remember I said the rocks in our pitcher of water. Here's the same thing. We put copper in the bottom of a little glass of water. Well, the copper's not going to dissolve in the water. So you can actually see it. And so that's a heterogeneous mixture. I can see the separation between the water molecules and the copper atoms. Okay, so we're going to do a little practice. And what I did for you, and I posted this to Moodle, is here are the problems that are inside of your textbook. And I just want to work through them. We'll do the odds on the video and we'll do the evens in class. So you have a little bit of practice with the lecture that you just had. So this is a type of problem that you would see. Classify each of the following as pure substance or a mixture. Okay, so iron. Iron you're going to find on the periodic table, that's Fe. Fe is iron. So it's one atom. So that must be a pure substance. Gelato. This is, if you've never heard of gelato, gelato is a Italian ice cream. And so if you think about even how ice cream in general is made, right? How do you make ice cream? Well, you have to follow a recipe. If you're going to follow a recipe, you're going to put multiple things in there. So you're going to have like some milk in there. You're going to put sugar, right? You have some flavorings, L-A-V, flavor. Do you like strawberry? Do you like, all the different flavors? So if you have all these things together, this is going to be a mixture. It's not just one thing. Cinnamon. Now this one, you think, oh, it's just all cinnamon, but what is cinnamon? Cinnamon is actually a plant product. It comes from a plant. And so if you think of anything that comes from a living organism, it's going to be made up of a bunch of different things. So it's a plant product. So plants have things like cellulose. They have things like proteins. proteins. So they're made up of all kinds of different things. They go on and on and on and on. So it's not just one thing. It's a bunch of different things. And if that's true, then it is a mixture. It all looks the same. So that would tell you it's homogeneous. But here we're asked just either pure substance or a mixture. Okay, the last one, spring water. Spring water. Spring water is something that comes out of the ground. Unless we say pure water, it's not just water. So if you think about water that you get out of the ground, what's going to be in that water that's in the ground? Well, you're going to have dirt, right? You're going to have minerals, all kinds of things that might be in that water. Maybe you got a fish in there, right? I don't know. So this is definitely a mixture. Okay, so I'm going to skip the even ones and we're going to go on and we're going to do the odd. Classify each of the following mixtures as homogeneous or heterogeneous. Briefly justify your answer. So let's go ahead and classify them and then we'll give a justification. So a bowl of vegetable soup. This is what we said. You could pick out individual things. If you can pick out individual things, we have things that are different. And we call things that are different a heterogeneous mixture, and called things that are the same homogeneous mixture. So a bowl of vegetable soup must be heterogeneous. Mouthwash. When you go and look in the sink in your bathroom, what are you going to see in your sink, in your mouthwash container? Should all be the same color. Maybe you like the blue, maybe you like the green, whatever. But it should all look the same. If not, you probably should replace that. So if it all looks the same, it is homogeneous. An unopened can of soda, and I would change that to a bottle, right? Because you really can't see through a can. But when you do that, what you're going to see is that it all looks the same. So this is homogeneous, right? And a dinner salad. Dinner salad, ooh, I need some lettuce, I need some tomatoes, I need some croutons, some cheese, all kinds of different things. And I can actually pick them out if I don't like them. Say somebody put olives on my salad and I didn't want olives, I could pick those off. So those different things that we can see, we have to classify that as heterogeneous. Okay, but now we have to briefly justify our answer. So for A and C are heterogeneous, what we could say is that we have a non-uniform composition. That is for our heterogeneous mixtures. Now for our homogeneous mixtures, this would be a uniform composition. Okay, so those are our problems for the first section. That's it. See you next time.